Okay, so I promised you a few more examples. I'm sorry, I don't know why this looks so distorted. It wasn't like this when I was doing it earlier, but it's weird now, and I'm sorry. Okay, so anytime that we want to write any kind of definition, whether it's closed form or whether it's recursive, the first thing we need to do is we need to create a difference table. So we're going to do a delta column, and we're going to do a delta 2 column. So, all right, this one is only going to have 1 blocked off, this one is going to have 2 blocked off. 12 minus 5 is 7, 5 minus 0 is 5, and 0 minus negative 3, which is the same thing as 0 plus 3, is 3. So if we look at this, we know that these differences are not the same. That means that we have to do another difference column. So 7 minus 5 is 2, 5 minus 3 is 2. So from here, what we can do is we can do the recursive. Okay? And if you remember, a recursive starts out the same way, and I'm going to use n and b of n, so I'm going to do f of n. Sorry, I should be using b of n. So whatever notation they use is what we should be using. So b of n is equal to, now this first line right up here is going to come from this one right here. So this is negative 3 when n is equal to 0. And then we start off this part the same way. So f of n minus 1, haha, like how I did that, plus, and then we've got to figure out what's going to go in here. So remember, what we do is we take the delta 2 column, and we're going to do 2 times x minus 1 plus whatever our delta column is. So remember, this is the part where we're ignoring this one and we're pretending like this is our new output and this is our new delta column. So we do plus 3 here at the end. And then all we do is distribute. So 2 times x is 2x and 2 times negative 1 is negative 2. And then once you do that, combine your like terms. So 2x plus 1. That's what's going to move to this spot right here. So 2x plus 1 when, sorry, I'm using x's. I should be using n's. I'm so sorry, you guys. When n is greater than 0. So now remember, for closed form, okay, let's do the closed form here. We know that because it ends in the delta 2 column, that it's going to be a quadratic function. And a quadratic function has a highest degree of x squared. So we know it's going to be something x squared with something here and something back here. Well, the something back here, remember, this is just our constant. And remember, that's going to come from this piece right here. So this is going to be our negative 3. And if you remember, the coefficient on x squared is going to come from our delta 2 column. And we just have to divide that by 2. So 2 divided by 2 is 1x squared. We just have to figure out what goes in here. So the first thing we're going to do is we're going to take this and we're going to create a column for it. So 1x squared, or just x squared. Okay? So we're taking, sorry, this should be n's again. Okay. Keep switching it up on us. Okay, so we plug this in. So 0 squared is 0, 0 times 1 is 0. 1 squared is 1, 1 times 1 is 1. 2 squared is 4, 4 times 1 is 4. 3 squared is 9, 9 times 1 is 9. So this is where this is our n squared column, which comes from right here. The next thing we're going to do is we're going to take our output, which is this one right here, this b of n, and we're going to subtract out our 1n squared. Okay? So start with b of n, negative 3 minus 0 is negative 3. 0 minus 1 is negative 1. 5 minus 4 is 1. 12 minus 9 is 3. And then all we have to do is find the delta for this. So 3 minus 1 is 2. 1 minus negative 1 is the same as 1 plus 1, which is 2. Negative 1 minus negative 3, same as negative 1 plus 3. which is 2. So because it's positive, we're going to do plus 2n in that box, and that's our closed form for this one. I'll try not to mess up the next one so bad. All right. So on this one, same thing. Excuse me. We need our delta column. We need our delta 2 column. And we're eventually going to have to stretch that out. Okay, this one is x'd out, and these two are x'd out. So 90 minus 52, 38. 52 minus 24, 28. 24 minus 16, 18. And 6 minus negative 2 is the same as 6 plus 2, which is 8. So if we look at this, not linear because it's not constant. So now we come over here and find our delta 2. So 38 minus 28 is 10. 28 minus 18 is 10. 18 minus 8 is 10. So if we're doing our recursive, okay, we do f of n is equal to, and it should be y of n, I just realized, I'm sorry. Start with this one. That's your negative 2 when n is equal to 0. And now this is the part where we're going to ignore this one again. Okay? So remember, take your delta 2 column, and you're going to take 10 times x minus 1. And remember, this is our new output, so we're going to add this 8 to it. This part right here is just going to be f of n minus 1 plus something when n is greater than 0. We just have to figure out what this something is. So we distribute 10x minus 10 plus 8. Combine our like terms, 10x minus 2, and put this in here. So 10x minus 2. And, sorry you guys, for when n is equal to 0. All right, so that's recursive. Then we'll do the closed form. Okay, again, because our constant term is in the second column, in the delta 2 column, that means that it's going to be a quadratic, so we need to have something n squared. And the way that we get this something is we take our delta 2 constant and divide it by 2, so this should be 5n squared plus something in here, and then we can unignore this one again. Okay? And then this is going to be the constant at the end, so minus 2. And then the way that we do this, we put this up here, so 5n squared. Okay? So remember, square the n first, then multiply times 5. So 0 squared is 0 times 5 is 0. 1 squared is 1 times 5 is 5. 2 squared is 4 times 5 is 20. 3 squared times is 9 times 5 is 45. And 4 squared is 16 times 5 is 80. Okay? So the next thing we want to do is we want to subtract this column and this column. So we want to do the y of n minus the 5n squared. Okay, remember this is going to be empty. Oh no, it's not. I'm thinking of difference. Don't listen to me. It's been a long day. Okay, so 90 minus 80 is 10. 52 minus 45 is 7. 24 minus 20 is 4. 6 minus 5 is 1, and negative 2 minus 0 is negative 2. Can you guys hear that cheering? Okay, so now we're going to do our delta. Just start at the bottom and subtract your way up. So 10 minus 7 is 3, 7 minus 4 is 3, 4 minus 1 is 3, 1 minus negative 2, same thing as 1 plus 2 is 3. Now, if this column doesn't come out constant, it means that we've made a mistake in one of these other columns. So because our delta is constant and because it's positive, we're going to put plus 3n inside that box. Okay, one more. This one's a big one, so it's kind of tricky. And this one is a good one because it has a negative coefficient. So again, let's start with our delta column. So 344 minus 306 is 38. 306 minus 236 is 70. 236 minus 134 is 102. And 134 minus 0 is 134. So we can see that this is not a linear function because the delta isn't constant yet. So we're going to go to our second delta. And we're going to work our way up. So 38 minus 70 is negative 32. 70 minus 102 is negative 32. 102 minus 34 is negative 32. So in our recursive, we're going to do S of t, because that's what they have up here. I looked, is equal to, okay? This is going to be 0 on top, because that's what our output at 0 is. So when t is equal to 0, and then down here, this is going to start the same way, S of t minus 1, and then we have to figure out what goes here when t is greater than 0. So again, we're going to take our delta 2 column, we're going to multiply it times t minus 1, and this is, we're ignoring this part right now, so this is like our new delta, this is our new output at 0. We're going to add 134, okay? So negative 32 times t is negative 32t, and then negative 32 times negative 1 is positive 32 plus 34. So combine our like terms. It should be 134, sorry. So negative 32t plus 166 is what's going to go up here. So negative 32t plus 166 when t is greater than 0. There's our recursive. On to closed form. Okay, so we don't need to ignore this anymore. Okay, so first thing we're going to do is, because this ends in the delta 2 column, we know that this is a quadratic function. And so we know that the first term is going to be something t squared. And we know that the last term is going to be plus 0. And we just have to figure out what goes in this spot right here. So the way that we figure out this is we take our constant term, so negative 32, and we split it in half. So negative 32 divided by 2 is negative 16. All right, so then we're going to take this term right here, and we're going to pop it up here. So negative 16t squared. And remember, we're going to go all the way down. So plug this in first and square it first, then multiply it times the negative 16. So anything times 0 is always 0. Anything times 1 is always itself. Okay? 2 squared is 4. 4 times negative 16 is negative 64. 3 squared is 9. 9 times negative 16 is negative 144. And 16 times 16, negative 16, is negative 256, okay? So the next thing we're going to do is we're going to take our output and we're going to subtract negative 16 squared. So what it's going to look like is S of t minus a negative 16t squared. So because it's got these two negatives here, really what we're saying is S of t plus 16t squared, okay? So we're going to take this column and we're going to add this column and add this column, this column, add this column, this column, add this column. Okay, so if we take 0 plus 0, we get 0. If we take 134 plus a negative 16, we get 118. If we take 236 and add a negative 64, we get 172. If we take 306 and add negative 144, we get 162. And if we add 344 plus a negative 256, we get 88. Oh my gosh, what did I do? I made a big, huge mistake somewhere. Hold on, guys. Oh, duh. So I just was telling you this the whole time, and I was doing what I shouldn't have been doing. If you're subtracting a negative, you're adding, so these are all going to be positives. So 134, good grief, plus 16 is 150. 236 plus 64 is equal to 300. 306 plus 144 is equal to 450. And 344 plus 256 is equal to 600. Duh. I just wrote it right up here and then I didn't even follow my own instructions. Okay, so now we look for our difference. If we start from the top and subtract, or start from the bottom and subtract up, you can see that every difference along the way is 150 and it's positive. So we would put plus 150t into that closed form definition. So there you have it.